Welcome back, guys. In this video, we got to take this rational expression, divide it by this one. We have to simplify it and we have to state the restrictions. So, same steps as we did before. First thing you want to do is you want to factor everything. So notice y squared minus 4x squared, that's a difference of squares there. That's going to factor into y minus 2x, y plus 2x. The denominator, notice from both of these, we can take out an x squared. Notice how x is common in both, and you take out the lowest exponent always. We can't take out any y's because only this expression contains a y. This one doesn't. So when we take out an x squared, what are we left with here? We'd be left with 2x plus y. Then we're going to be dividing. From here, what can we take out? We could take out a y cubed. So we'd be left with 2x minus y. And then over here, x to the 4, can't factor that any further. So we just leave it as is. So first step was factor. Second step, before we simplify, we want to get the restrictions. Now, the restrictions are always what? The denominators can't equal 0, right? You can't be dividing by 0. But notice since we have a division symbol here, we also have to take into account the numerator of the rational expression that we're dividing. Because remember, if the numerator is 0, this whole thing is 0, and you can't be dividing by 0. So when you're dividing by a rational expression, you got to take into account the numerator as well. So let's start off with the denominators though. We got x squared here. So x squared cannot equal 0, which means x cannot equal 0. And that's one of the restrictions. Here, 2x plus y cannot equal 0. You pick one of the variables to isolate for. Usually I'm isolating for x, but in this case I'm going to isolate for y. Just switch it up a little bit. So bring the 2x over, that becomes negative 2x, so it means y cannot equal negative 2x. And then here, x to the 4 can't equal 0. That's the same as this restriction. X cannot equal 0. And then we have to look at the numerator of this second rational expression as well, because we're dividing. So y cubed cannot equal 0, which means y cannot equal 0. And then over here, we got 2x minus y cannot equal 0. Since we isolated for the y here, let's isolate for the y here. Bring the negative y over. So basically, y cannot equal positive 2x. And then these two here, since they are the same, just the sign is different, you can actually write this as 1. So you could write plus or minus 2x. Y cannot equal plus or minus 2x. So you may see it, you may see the solutions in your textbook like that. But either way, there are 4 restrictions in this case. And remember, we had to take into account the numerator here because we are dividing. If we were multiplying, then we would just ignore these factors here for the restrictions. We would just be, the only restrictions would be these two here. But since we're dividing, got to take into account the numerator. You add on those 2 restrictions as well. Okay, so we have all of our restrictions there, and now we just simply have to simplify. So when we are dividing, what is happening? We flip that second fraction, and then we change this to multiplication. So we'd have x to the 4 up here, then we'd have y cubed 2x minus y. So now we combine everything. Notice that y plus 2x, 2x plus y, those are the same thing. Right? We could just take this 2x, bring it in front, it'd be 2x plus y as well. So these two are going to cancel out. We got x to the 4, x squared here. So we got 2x's at the bottom, 4x's at the top. You know what, actually? Sometimes you can do this sort of cross canceling, but I see a lot of students making mistakes sometimes when they're doing this cross-canceling. So you know what? I would just take an extra step here and I would combine everything. So these two, easy to tell that they cross out because they're right on top of each other. But this one, let's bring in front. So we got x to the 4, we got y minus 2x. And then here, x squared, let's bring the y cubed in front, and then I'm going to have 2x minus y. Okay, we're going to further simplify. It's just easier to see now what's going to be happening. So this x squared here, there's 4 x's at the top, 2 x's at the bottom, so we're going to be left with 2 x's at the top. There's no y's to cancel out with the y cubed, so that just stays there. Then 2x minus y, y minus 2x, those are almost the same, but we can make this y minus 2x equal to 2x minus y by factoring out a negative. So if we take out a negative, put it in front, so we got the negative x squared here. This x squared goes away. This is going to be all over y cubed. Since we took out the negative from this, the signs change, so we're left with positive 2x minus y. And this is 2x minus y. And then those will cancel out right there. So final answer, negative x squared over y cubed. All right, so if you do feel comfortable canceling stuff out like this, right, crossing it, so you would have to first take out a negative from here, and then these two would cancel out, then x4, x squared, you can do that, and then you could get to the answer right away. It's just sometimes I see students making mistakes when there's stuff like on one side and then on the other. So sometimes it's better to just combine it first and then simplify. But if stuff is right on top of each other, you could just cancel it out. It's pretty easy to see there. Right? Either way, that is your final answer. Those are the 4 restrictions.